So when we're being asked to factorize an expression, algebraic expression like this one, what we're being asked to do is write this same expression but in a different fashion, and a fashion that gives us some other information about the expression that's quite useful. In particular, the information that we're looking for is information about the factors of that expression. And we've come across factors before, before we got to algebra, in fact, when we were just talking about numbers. When we talked about the factors of a number, so say 12, for instance, we were talking about those numbers that multiply together to make 12. So, for instance, the factors of 12 are 1 and 12 because they multiply to make 12, 2 and 6, and 3 and 4. All of these numbers are factors of 12. But when we're being asked to factorize something that's a little bit more complicated like this, what we're really looking for is all of the factors that are common to all of the terms in our expression. So if we start with the numbers, because that's what we're familiar with already, we can say, well, we know what the factors of 12 are. It's all of these things that we've listed over here. We can also have a look at the factors of 4. It's 1 and 4, and it's 2 and 2, and realize that 12 and 4 do have a couple of common factors. They've got 1, 2, and 4 as their common factors. And of those, 4 is going to be the most useful because it's the highest common factor. And so when we factorize, what we can do is we can identify that there is that highest common factor of 4 there, and we can take it out of this expression. We do that by putting in brackets. So we've got 4, and then we open a bracket, and then what we're going to have on the inside is what we'd need to multiply by the 4 to make our original terms in this expression. So if we wanted to have 12x, we need to do 4 multiplied by something to give us 12x, and that then is going to be 3x. 4 times 3x will be 12x. Similarly here for this second term, we want to have 4 times something to give us 4xy. So if we have xy inside this bracket, 4 times xy is 4xy. So this is effectively the entire process for factorization, looking to find a way of writing that expression in some different form. So you've got something multiplied by something else to give you the original form. But we can go further than just looking at the numbers, and we can actually work with the variables as being common factors as well. So if we look in this term, we've got an x as part of the variable, and in this term there's also an x. And because this is 3 times x and this is x times y, it is a factor because it's multiplying part of that term. So we can take that out as well, and we can write this then as 4x. And on the inside here we'll have we've just taken our x out, so there'll be 3 left over, and we've taken the x out of this, so there'll be y left over. So that then is our factorized form, and it is exactly the same expression that we had above. It's just written in a different way that tells us what the common factors are of all of the terms that we had. It does exactly the same thing. We can check it, because if we multiply this back out, we'd have 4x times 3 would give you 12x, and you'd also have 4x times the y would give you 4xy as we started with. But this then is our nice factorized form for that expression. This second example looks quite a bit more complicated, but we can apply the same process that we did to the first example, and we can go through it step by step as well. There's no need with factorization to try and see the entire factorized form all in one go. You can break it down bit by bit. So if we wanted to look to factorize this expression, we could start by looking at the numbers, and we could start to see if there is anything common between all of those numbers. We might spot the highest common factor immediately, but even if we don't, we can still see that each of those numbers is an even number. So as a starting point, before we go anywhere else, we could factorize out 2. Inside our brackets then, what we need to have is some terms that will multiply by the 2 to give us the term that we had originally. So if we want to make 24 lots of a squared times b times c, then we need to have 12 on the inside. So we get 2 times 12 gives us that 24. And we leave the a squared bc as it was before. Similarly for this term, 2 times 9 will make us 18. and then a cubed b squared. And finally over here, it's a negative, and 2 times 18 will give us 36. And then we've got this brackets AC all squared. So we've taken out 2 from our numbers, but what we should be looking to do is seeing if we could have gone any further, see if there are more factors that we could spot. And so we look at those numbers again. So we've got 12 and 9 and 18. And what we can realize is that actually they're all multiples of 3 as well. We could have potentially spotted that up here and seen it was all going to be multiples of 3 in the first instance, but the point is we didn't have to. We can take it step by step. There's no need to do it all in one go. If we're going to take out that 3 though, it's going to come to the front here. We've already got the 2 out there. The 3 that we're now going to bring out is going to multiply by the 2. So we'll end up with 2 times 3 and have 6 on the outside. And if we have a quick look here, we could have potentially spotted it to start off with because we can see that each of those 3 numbers is a multiple of 6. But we've done it this way. So we've just taken out a 3. So we've taken out 3 from 12, which will leave 4. And then we've got the a squared bc as we had before. And then we have removed that multiply by 3 from the 9, so that's going to leave 3 there. And then we'll have a cubed b squared. And finally, we're dividing the 18 by 3 as well to get 6. And then this AC all squared that we've got there. At this point, we can just confirm that that's fine. 6 times 4 will be 24. 6 times 3 is 18. And 6 times 6 is 36. So we're happy so far. The next thing we want to do is, as with the previous example, we want to have a look at the variables and see if there's anything we can take out from there. This expression here is going to hinder us a little bit though, because here we've got separate A, B's and C's, but here they're all lumped together as one thing. So we probably want to do some work with that first of all. And what we can realize, and the way I've phrased it so far is I've said AC all squared. So that means everything inside this bracket has been squared. So quite simply, that means the A has been squared and the C has been squared. So we can write that out now. And even though we're not changing anything else here, it's still best to write out the full expression so that you can keep track of what you're doing. It doesn't take too long. But then rather than writing AC all squared, we can write A squared, C squared. And that means exactly the same thing. So now we want to have a look at our terms and see what's common with these various things. I'm going to come back to the A's in just a moment. Let's have a look at the B's first of all, because we'll realize that we don't have to worry about them. We've got a B in this term, and we have a B in this term, but because there's no B's in this term, it's not a common factor to all of the terms in our expression, so we can't take the B's out. Similarly with the C's, there's a C in that term, and there's a C in the final term, but there isn't a C in the middle term, so C isn't common to all of the terms, so we can't take that out either. Going back to the A's though, there are definitely some A's in all 3 of these terms. We just need to think about how many we're going to take out. That's A squared, that's A cubed, and that's A squared. And so the only thing that we need to realize is that our A cubed, remember that just means A multiplied by A multiplied by A. Or another way of putting that, ooh, that's exciting. So we're just going to go horribly wrong there. Let's try that again. I don't know what I said before. So we'll see if this works. Looking at that A cubed, we can realize that another way of writing A cubed is A multiplied by A multiplied by A. It's just going to be annoying, isn't it? Can't write that close to the thing, can I? Whew. And we can look at that A cubed and realize that another way of writing that A cubed would... And we can look at that a cubed and realize another way of writing it would be a multiplied by a multiplied by a. Oh, seriously now. I am getting fed up with that. And we can look at that a cubed and realize it's just the same thing as a squared multiplied by another a. So what we can actually do here, we've got an a squared here, we have an a squared in here as well, and we've got an a squared there. So we can take out a squared as a common factor. And that will leave on the inside of this one, we've just taken out a squared, so we'll get 4bc. Here we've taken out a squared, which leaves one remaining a from the a cubed, so that'll be 3ab squared. And then finally from this one, we'll take out the a squared to get 6c squared. A quick double check to see that there's nothing else we've missed. We haven't got any common a's there. We haven't got enough common b's. We haven't got enough common c's. And if we look at 4, 3, and 6, they haven't got any common factors either. So that's going to be factorized as far as we can go.